And good afternoon, everyone. Welcome back to lecture 2, class meeting 2. I don't know what the heck. So, Biochem of Foods. I have my favorite food with me. And let's see. So it's Monday. I'm going to drop this one Monday evening. I'm going to put on with this a sort of a summary of the chemistry of small molecules and a sort of, not really a lecture outline, but sort of the topics we've covered. Because the way we're going to run this is next week we're going to have an exam. And I haven't quite figured out exactly how we're going to do the exam. I think, ideally, what I'd like to do is on Moodle, I can tell when you open something up, and I can tell when and I think that I can like put a time limit on it when you have to turn it back in. And that's kind of like what I'd like to do. That is, give you an hour for the exam. And just so you know about the exam-wise and the way I'm thinking, this is a non-majors class, non-majors biochemistry. As I say, you have to really work hard to make a D or an F. Pretty hard to make a C. What that means is, if you come in, you watching videos, you give me your best shot, we're not going to have any problems. Now, if you want to make an A, you probably have to make an A on at least a few of the exams. But to be able to, pass the class, come on, we're not going to have any issues. Furthermore, I was thinking then about at Texas A&M, we had our student creed, which we probably have one here too, but I'm not sure what it is. And that was, Aggies shall not lie, cheat, or steal, nor do they tolerate those who do. And I remember I had a roommate my sophomore year who was engraving his trigonometry formulas onto the front of his calculator. And I felt terrible because he was cheating and I was tolerating it. That's victim shaming, man. I was a victim. So my rule is, we will not lie, cheat, or steal, but you ain't gonna rat on nobody. Nobody likes a rat. Snitches get stitches. So what you can do then is get with your partner, find somebody you know in the class, you open their exam up, you work through it, they take the hit, then you open your exam and you know the answers and you do really well. And then for the next exam you swap. See? That'll work. Whatever. Look, if you're that concerned about this class, you shouldn't be. But that said, yeah. All right. So now, let's have a quiz. So pull out a sheet of paper. Whatever. Like what I'm watching? No. But literally, legitimately, this is what the first quiz would be. It is this. Write out the 3 major bond types in order of their strength and define them. And then 2, diagram 2 water molecules engaged in hydrogen bonding. So take a few moments and do that. Tick, 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 tick. Bing! Well, you could have stopped the video, man. I need more time? Pause. What do you want me to do? Normally what that would happen is I'd go get my coffee, I'd sit around for a moment and give you 10 minutes. And then you hand them to me, I look them over and go, well, whatever. So this isn't that much different, all right? Now, so the answers are, go ahead and raise your hand, and check off. 1 is for bonds. Covalent is our strong one. Equal sharing. Number 2 is ionic and unequal sharing. Now, you probably on the exam would write an unequal sharing of electrons, but I ain't doing that. All right? I'm talking to you. We can do an oral test if you feel more comfortable. All right, and 3 is the hydrogen bond, and this is going to be the partial charge on O and the partial charge on the hydrogen, and it is the charge attraction. All right, so that's good enough for me. Now, in terms of 2 water molecules engaged in flagrant hydrogen bonding, we draw a water molecule of H2O, and then remember, oxygen's got a slightly negative charge. Beep, 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 beep. Here is hydrogen. And hydrogen has a slight positive charge, and that is the hydrogen bond right there. So, how'd you do on the quiz? Now, do you get partial credit? No. Hopefully you say, yeah, I knew this. I'm down. All right, so let's see. We last finished up talking a little bit about pH. That is a measurement of the hydrogen ion concentration, but it's done in a slightly funny way in that a pH of 1 has the highest concentration of hydrogen ions. pH of 14 has a lower concentration of hydrogen ions. pH of 1 is acidic. pH of 14 is considered basic. pH 7 is neutral. And so, as we said, your blood, sweat, tears, that kind of stuff, various fluids in your body, they're around pH 7. All right. We then went through some of the basic chemical symbols of the elements that we need to know: carbon, hydrogen, oxygen, nitrogen, calcium, phosphorus. Yeah, pretty much that's the bulk of them. We now are going to continue on with a little bit of chemistry, and what I'm going to do is maybe over here. Yeah, no, over here. We've got some white space. I'm going to write a little bit of an outline, kind of what I want to try and cover, and I will also make note that just because, like having a class, we lecture for a while, we do stuff, then I take a break, we lecture again, do stuff. Having to lecture nonstop straight for like 2 or 3 hours is demoralizing. And so I'm probably going to drop this week's lecture over a couple of days, i.e., I'll probably do some more gassing on about organic chemistry and macromolecules tomorrow. But this is what I'm hoping to cover for the week, and it is the following. Let's see. We've covered, so we're going to get into organic chemistry. What are known as the functional groups in organic chemistry. And then getting into what are known as the macromolecules of food. And it turns out those are also the macromolecules of biochemistry. Can you read that? Yeah, good enough. All right, so the macromolecules. So these are my basic topics. And the macromolecules of food, that's really, a lot of stuff there. We're going to begin talking about carbohydrates, fats, and proteins, and just exactly what it is they are. What are they? Or what are they is. And that's what we're going to have our exam on. Okay? So, there you go. Now, for this week, we actually are going to try and do a lab of sorts, in that I'm probably going to put together, I bet around Wednesday or so, a little demo that you will follow along if you like. If you don't want to, hey, what are we going to do? So between now and next time, Wednesday, you need to find yourself some good lemonade. None of this Kroger crap. Like real simple lemonade, and you can get them in those little smaller containers, and that's fine. You can make your own homemade lemonade. That's good. If you really want to get technical, then you're also going to need some baking soda. Now, if you really want to get technical, you could also get yourself a packet of Kool-Aid. And it just occurs to me, I might buy packets of Kool-Aid, and you can come by and pick one up. Wouldn't that be a nice way? We can meet each other a little bit. I don't know. Yeah, it's your lab stuff. I'll send you an email or something like this if I decide to do that. All right, so real simple lemonade. What?
Simply lemonade.
Oh, simply lemonade is what Igor tells me it's called. Baking soda, just need a pinch, and a cup, some kind of drinking container, and we'll see what mischief we can get into.
Red silver cup.
All right, so let's see. Let's jump into some chemistry, shall we? Sure. All right, we were talking a little bit about bonds, talking about pH, talking about the structure of the atom and elements, and this is the nuts and bolts of all chemistry, but kind of like in the class inorganic chemistry is where you cover this kind of stuff. What we're going to turn our attention to now is the chemistry of molecules that contain carbon. This is known as organic chemistry. And it's just as a little interesting, amusing note, if anything, I'm filled with amusing notes. Organic chemistry is the realm of the petrochem biz, like big oil and plastics and real serious kind of pesticides and things like that. These are all made with lots of carbon molecules, organic chemistry. And when people talk about organic food, the term organic has the connotation that it's made without pesticides and without herbicides, and it is done in a more natural fashion. But the term organic might indicate, or would indicate, that you're using lots of organic materials and major pesticide, herbicide use, and man-made materials. But that's kind of a joke because, see, most people assume organic means more natural, but organic chemistry is the chemistry of all these massive carbon molecules. On the other hand, all living things are based on organic chemistry, as we're about to see. So, our university offers a 2-semester class in organic chemistry, and you don't need no 2 semesters. I can teach you everything you need to know about organic chemistry in about 15 minutes. Here we go. All right. So, organic chemistry is the chemistry of carbon-containing molecules. Carbon, of course, is written as a C. CC. And carbon always has to have 4 bonds. Now that means we need to always have 4 lines coming out from every carbon atom. All right? So organic chemistry is filled with all kinds of nomenclature and vocabulary. We need to know a little bit about it. And I'll tell you, organic chemists are kind of like Masons, maybe. I don't know. They have their own secret world filled with terminology to keep the rank and file from knowing what's going on in the organic chemistry world. I'm going to let you in, though, on some of their secrets. But there is a lot of terminology and vocabulary that is a bit of a drag. Still, we'll deal with it. All right, so now, this could be actually my Millikan picture. C is for coffee. And that's good enough for me. Now, carbon. So, one of the things about organic chemistry as well is that we can predict different things about the molecules based on their composition. And there's some very specific predictions that come about, and we'll be getting into that a little bit. So, carbon, the simplest carbon molecule or organic molecule is a carbon that has 4 hydrogens on it. This is written also as CH4. And you know this because, or you know of this, this is called methane. So the first set of vocabulary bits that we need to work on is the naming of the organic molecules based on their carbon number. And what we're going to do is just start working our way through them with little bits of pieces as we go. And one carbon is methane. We have something what we're going to make is something called a straight chain hydrocarbon. It is nothing but carbons and hydrogens. We're going to start adding more carbons and hydrogens. The next one on the list, you guessed it, is 2 carbons. Now, because we've got a carbon-carbon bond here, they only have 3 hydrogens each. All right, so we got, I might have a erase because I was a bit big in my methane here. We have 1 carbon is methane. It is also known as a methyl group. Now, just so we know, and just we say this, the organic chemists for these first couple of them have alternative names just to keep the uninitiated from knowing what the heck's going on. A methyl group is also known as a formyl group. So if you've ever heard of formaldehyde, it's a 1 carbon molecule, or formic acid, which is an amphites, a 1 carbon molecule. All right, so 2 carbons. 2 is ethane, and it's also known as an ethyl group. And that's actually kind of a standard thing, is that you can take the first, it's ethyl, methyl, butyl, propyl. But ethane, or 2 carbon molecules, are also given the term an acetyl group. And as we get into the biz, we'll talk about acetyls and things like acetic acid, 2 carbon. So it's one of the alternative names for a 2 carbon molecule. The ethyl group or the acetyl group. And Igor, if we have 1 carbon, then we have 2 carbon, what would be the next one?
Try something.
3 carbon. Thank you, Igor. Go back to sleep. 3 carbon. The 3 carbon molecule is the propyl group. Also, if it's just 3 carbons, it is propane. Now, just to put a little bit of, introduce these guys a bit. Methane, this is natural gas, is almost all methane. Ethane, nobody uses ethane for much. We'll talk about some things there in a little bit, but, natural gas has some ethane in it, but ethane ain't much. Propane, maybe everybody knows propane. You get propane in that little tank that you hook to your barbecue grill, and you have your barbecue propane. So this is 3 carbon. Now, we're gonna keep on going. 4 carbon. 4 carbon is butane. And a 4 carbon molecule, you know this if you've got your little Bic lighter, it's a butane lighter. For completeness, 5 carbon is pentane. And the truth is, in terms of foodstuffs and things that people are familiar with, 4 carbon is probably about it. 5 carbon is pentane. 6 carbon is hexane. 7 carbon is heptane. And the only reason I need to go up here is 8 carbon is octane. That's gasoline, basically. So when you're filling up your car, you'll notice that the fuels will have different octane ratings. It is a measurement of how much this burns compared to pure octane. So like race cars might run pure octane, I don't know, whatever. But octane, 8 carbon. And that's what gasoline is straight chain hydrocarbon. All right. Now, here's a couple of other bits and pieces to think about. First off, one of the predictions we can make, and it turns out to be true, is that the more carbons you add, the higher the boiling point is. Yeah, that's what it is. So, more carbons means it's more likely to be liquid at room temperature. Now, what that means is methane has got a very low boiling point. Methane boils at around minus 170 degrees, minus 200 degrees. I don't know exactly, but it's real butt cold. There's no place on the planet that's so cold that methane is a liquid.
F-C.
Next is ethane. Ethane, again, really, really cold in terms of its boiling point. Now, propane is also very, very cold. But here's one of the points. That in order to make these things liquid, you have to put them under high pressure. And the lower the boiling point is, the colder the boiling point is, the more pressure you got to put on there. So methane, to make that liquid, is a lot of pressure. And there are liquefied natural gas plants, and liquefied natural gas is a commodity that is now shipped across the world, but it is a really dangerous material to mess around with because it requires a lot of pressure to keep it liquid, and it's very, very cold. Ethane also. Now, when you get to propane, the boiling point of propane is pretty darn cold, but you can apply a modest amount of pressure and have it be liquid. And it's not so dangerous that you can't give it to somebody at Lowe's and have them take it in their tank. Now, butane is really an interesting one because you may have seen or have a butane lighter. And butane has got a boiling point of 21 degrees Fahrenheit, 22 degrees Fahrenheit. If this were wintertime, we actually could go out in the parking lot, crack open a butane lighter, put it into a bowl, and as long as it was below 20 degrees, it'd be liquid. Now, as soon as you put your hands around it and start warming it up, it would start boiling, which would be pretty cool. The point there is because it doesn't require so much pressure to keep it liquid, they can put it into a little plastic tube, and the pressure can be held in that little plastic big lighter. So butane, no big deal. Now, pentane actually is liquid at room temperature. Hexane, this is liquid at room temperature. It's got a boiling point of about 100 and something degrees. I don't know what. I got here a bottle of heptane, and the boiling point is 98 degrees centigrade. That is boiling water. So water boils at 100 degrees centigrade. So the more carbons you put on there, it raises the boiling point, and then we can begin to make these sort of predictions on the organic molecules this way. Now, another thing about organic chemistry that's important to note is that we can begin having different kinds of bonds and things going on. Now, what we're showing here is straight chain carbon, just carbon, carbon, carbon. And what's possible is to have what's known as a carbon-carbon double bond. Like that. That is, these two carbons are sharing not just one electron, but two electrons. So you diagram it with two lines going across it. So a carbon-carbon double bond. Now, what that means is they're going to have hydrogens like this, because now we have 1, 2, 3, 4 lines coming off this carbon, and the same here. And this is actually referred to, technically, this would be something called ethene, instead as opposed to ethane. It's actually known, though, as ethylene, and we actually eat ethylene all the time. Ethylene is a gas, as we would predict from only having two carbons, and it is the fruit ripening agent. It is what triggers fruit ripening. If you've ever heard about you can speed the ripening of avocados by putting them into a paper bag with an apple or a banana. It's because apples will give off a lot of ethylene, and that will trigger the ripening of your avocado. Generally these days, most fruit is picked in the unripened state, and it's taken to various sort of distribution centers, like around here, probably St. Louis or Chicago. And when they get ready to ship it to distribute to the grocery store, they'll take a big pallet load of tomatoes or bananas, stick them in a big tank, and flood the tank with ethylene and hold it there for several hours. That will begin to trigger the fruit ripening process. You pull them out, the fruit ripening has started, and you can begin distributing them, and then they'll actually start to ripen. And so when you see those bananas at the grocery store, in which they have the absolute green bananas saying ready in 3 days or 4 days, and then some yellow bananas ready in 2 days, and then some yellow bananas with black spots ready today, and then some really jank looking bananas that were ready 2 days ago, it has to do with how long ago they were ethylene gassed. Because when these things are picked, they're probably stored under cold nitrogen. And that's how they're shipped around. So rotting fruit, damaged fruit, actually can give off ethylene gas. So in fact, the Jackson 5 were wrong, because one bad apple can spoil the whole bunch, girl. Sorry. All right. So we see carbon-carbon double bonds in food all the time, no problem. Just for completeness sake, just because you're saying, hey, I know organic chemistry, there is a carbon-carbon triple bond. You never see it in food, but it looks like this. And this should be called ethine, but it is actually known as acetylene. They always change the damn names up. Anyway, if you ever run an oxyacetylene torch, that's the stuff you're burning. All right, let's see. Okay, that's really all the organic chemistry nomenclature that we need to know in terms of the different molecules. And let's face it, we won't be dealing with anything bigger than 3 carbon, probably at all. So methyl, formyl, ethyl or acetyl, propyl groups, we got you covered. Butane, the butyl group, pentane, hexane, heptane, octane, rock on. Now, what really makes organic chemistry sing, though, is the presence of what are known as functional groups. And these are side additions that can change the characteristic of these different hydrocarbon backbones. And, yep, you got to memorize these guys. So, here you go. And this is why you're writing this down, because you're going to write it down and it'll help you to memorize it. All right, so here are the functional groups that you need to know. They are, first, the alcohol group. And the alcohol group is an OH. So, in this specific case, we've got a carbon with an OH. That's one bond. We need that many more. There. This is known as methanol. Also known as wood alcohol. If you ever, like moonshine stories talk about methanol poisoning, we'll get into fermentation, and I'm just here to tell you that if you are generating methanol during your moonshine process, you're either working with something that smells so bad you got no business messing with it, or you're intentionally trying to poison people. Methanol is really nasty. Do not drink it. Methanol is the leading cause of induced blindness in the country. Methanol in the body is converted to a molecule without the OH, but just a double bond oxygen. And that double bond oxygen, take that H group off, that makes what we know as embalming fluid or formaldehyde. And you basically are pickling or fixing your eyeball. As it turns out, the treatment for methanol poisoning is to block or inhibit an enzyme that is converting methanol into formaldehyde. Your eyeballs tend to be very sensitive to it. And the way you do that is you flood the patient with ethanol, 2-carbon alcohol. And that's what drinking alcohol is. And so you get methanol, people that consume methanol, you get them as drunk as you possibly can, as fast as you can, and the system works where it's a competition reaction. And rather than breaking the methanol into formaldehyde, you break the ethanol or convert the ethanol into acetaldehyde, which you can detoxify. There you go. Anyway, that's the alcohol functional group. So let's just go back through that. The alcohol functional group, bada bing, it is COH. Now, remember, we talked about hydrogen bonds, and hydrogen bonds form whenever we have an OH. So we get a little bit of hydrogen bonding going on here. We got a negative there and a positive there, and that means that the alcohol molecules actually can engage in a little bit of hydrogen bonding. Now, it's not quite as good as water, but it's not bad, and one of the things it does is by adding that OH, we raise the boiling point of methanol up to probably like 150 degrees, 160 degrees Fahrenheit. It's methanol is liquid at room temperature. So that's the alcohol group. The next group is called the carboxylic acid group. Carboxylic acid. A carboxylic acid is a molecule that's going to act like an acid. That's a C, by the way. Carboxylic acid. And it looks like this. It's a carbon with an OH group on it, like alcohol. But now it has, in addition, an oxygen that's double bonded to it. So this COOH, that is the carboxylic acid. And for all of you nerds, it's that hydrogen there that actually can dissociate, that is providing the hydrogen for the acid. Carboxylic acid, if you look at this guy, we got 1, 2, 3 bonds coming off that carbon. If we put one right there, we have made formic acid, which is the active ingredient in ant bites. I've never eaten ants, at least not intentionally, but they would probably taste rather tart, kind of sour. Now, an acid that I have consumed frequently, and you have perhaps, is a 2-carbon acid. It looks like this. 1, 2, OH, double bond O, and then there's hydrogens over here. And this is the 2-carbon acid. So you could call it ethyl acid, but remember the 2-carbon is also the acetyl group. This is known as acetic acid. Now, acetic acid, maybe you haven't heard of, but if you dilute this down to 5%, you got what we call in the business vinegar. Now, vinegar can be produced naturally by taking sugars, wine, different things, and fermenting them and letting bacteria actually act on them, and they can create vinegar. But you can also create vinegar industrially and distill it. And 5% vinegar, or 5% acetic acid is vinegar. It is, at that concentration, not all that strong. You can drink vinegar. If you stick your finger into it for a while, it'll get a little bit white. And it definitely kind of makes your lips feel tingly. But I drink vinegar. I love vinegar. And that's not to say that it's a weak acid, though, because if you take vinegar and distill it, and you do this by separating out the water and making pure acetic acid, pure acetic acid will burn a hole in your pants pretty darn fast. You take your finger and stick it into pure acetic acid, pull back a bloody stump. Well, it'll probably give you a blister. I mean, it definitely will eat a hole in your pants, at least after you wash them. It is a reasonably strong acid. You're not going to dissolve anybody in it, but it's pretty strong. We've got some, I'm looking over at my fume hood here, we've got some concentrated acetic acid around the building, and you have to be careful with it. But diluted, it's vinegar. All right, so that's the second of our organic functional groups. We had the alcohol functional group and the carboxylic acid functional group. All right. Onward. Our third functional group is this. It is the amine group. Now, an amine acts a little bit like a base. And an amine has a nitrogen and a carbon. The nitrogen can have 2 or 3 hydrogens coming off of it, and the carbon, whatever you want to do. Actually, right here we're making something very close to being cyanide. It actually has some double, triple bonds in it, but CN is cyanide. You don't want to eat that. But so that's the amine group, is the nitrogen. Let's see. Now, another group that is a really important group is known as the phosphate group. And a phosphate group is a phosphate with 4 oxygens coupled to a carbon. Now, a really critical point to make with phosphate is this. Whenever you see phosphate, you must immediately think massive negative charge. And so, I always sort of work on this. I'm not one for camp cheers or for sing-alongs. Just don't do that. But I can envision a call and response. If you were here in the room, we would practice this. Because when I say phosphate, you have got to jump up and say negative charge. All right, let's try it. Phosphate.
Negative charge.
Phosphate.
Negative charge.
Phosphate.
Negative charge, probably.
That's it. So when I say phosphate, what do you say?
Negative charge, I'm pretty sure.
Negative charge. Thank you, Igor. Phosphate, negative charge. Now you're saying, what is he going on about? I think maybe I should be taking biology of birds. Au contraire. We will be fitting this phosphate molecule into things in a very serious way. It is not a stretch to say phosphates and their manipulation control everything. Everything including what are calories, everything including how your muscles contract, everything including the mechanisms behind cancer, all reside in phosphates. So when I say phosphate, negative charge, and we will see why that is.
Basically, the world is not run by Illuminati lizard people. The world is run by phosphates.
Thank you, Igor. You know something? We're going to stop this lecture right here. Phosphate.
Negative charge.